All right, and this is the throughput without any interference source and at that minus 70 or so signal level, which is also good to know. I suspect I might be having problems because of the constant power that I told these modems to use. Then again, the power is set pretty low, so shouldn't be clipping any amplifiers at this low power level. Anyway, that's what's to be expected without any interference. Let's turn on some interference. And that's what's to be expected with interference. But this interference level is coming in at, what is it, minus 12 dBm on the generator. And we achieved minus 41 dBm with 4 or 5 dB less interference power than that. So the actual interference power at the access point should be reading about minus 37-ish, 36 to 37, which is a really strong interference that I don't think I've ever seen come over an antenna from any of these transmitters that are adjacent to the ham band here. So that's okay. This is an unrealistic test and the modems are still doing okay here. Yeah, CCQ writing in the 50 range right here. 50 to 60 or so. And we're receiving at 9.7 megabit. So that's pretty good. This is certainly a better picture. Here, let me disable this. Than the spectrum analyzer mode would have us believe, right? Because here the noise floor is supposed to be minus 64, right? And this is completely bogus. I mean, how can you have a noise floor of minus 64 and then report a receive signal of minus 87 and continue working, right? So this is totally bogus. And really, if you recall, the turning off of that interference puts this receive signal around minus 70. So even still, minus 70 signal with minus 64 noise floor here would have made the situation totally unworkable. These modems need at least 20 or 30 dB SNR to do anything. So that would have been minus 6 SNR. That would not have worked at all. And yet, it works. Therefore, the spectrum analyzer is poop, but the actual modem function, not poop. So I'm happy with that test, and I think that's everything I wanted to get out of this. Can do a little bit of follow-up work and would need to write some software to do sweeps in terms of power levels and maybe spread basically measuring speed versus the interference power level, and then maybe how far in terms of spectrum you can spread the interference from the actual used channel before things start having a relationship and an effect. Here the interference is at 929.7 and the working frequency, the working frequency was 912, so whatever that works out to, that was the spread. So yeah, it'd be kind of interesting to see what happens when that pure sine wave moves closer, and as that pure sine wave is altered in terms of power and in terms of coming closer. That would be a nice double variable surface kind of result that could be plotted into a pretty 3D surface. All right, that's it for tonight. Enough science for the day.